So, there you go. Let's do that one. Your pinkness. Plan your work your plan. All is well with the world. So step 0 says we need to simplify, right? And nothing simplifies out of it. Even when I get it all the way factored down, nothing's going to cancel out. Okay? Right? So we can go on with what we need to do. Step number 1 says find the domain. In this case, it's going to be all real numbers, but x cannot equal plus or minus 2. Agree? Which tells me that I have vertical asymptotes at x equals 2 and x equals negative 2. Next, we got to find our horizontal asymptote. Degree on the top is 3. Degree on the bottom is 2. That's a big over a small case, correct? So that's none. But it differs by 1, right? Okay. So that's a none with a star. Because we're going to have a slant asymptote. Okay. Y-intercept is next. Plug in 0. So if I plug in 0 into my function, 0 cubed is 0. Minus 9 times 0 is 0, so that's 0 minus 0. All over 0 squared is 0 minus 4. That's going to be 0 over negative 4, which is still 0. So I get the origin for my y-intercept. X-intercept, I take the numerator, and I set all the factors equal to 0. And I get 3 x-intercepts. I get an x-intercept at 0, 0, 3, 0, and negative 3, 0. Do we have a hole? Anything factor out back at step 0? Nope, so we don't have a hole. Do we have a slant asymptote? Yes, that we do. Okay, so I'm going to move this graph down here a little bit, and then we're going to do, we'll scroll back up a little bit. And then we will do a little long division. x squared minus 4. I can't synthetically divide this one because it's not a linear divisor. So we got that. X squared, so then that would be x. So then x times x squared minus 4 is going to be x cubed minus 4x. Change the signs. Gives me negative 5x. And I can't do anything else here. So we're good there. So then we drop the remainder, which would have been whatever's left over. We drop whatever else is there. I don't even really care about it because we're just going to drop it. And so that would give me a slant asymptote of y equals x. Agree? All right. Let's put this on here we go. So we've got vertical asymptotes at 2 and negative 2. We've got a y-intercept at the origin. We've got x-intercept at the origin, at 3, and at negative 3. We've got a slant asymptote there. All right. So we did 3 already. Let's do negative 4. Oops, I gotta get back my function. What was my function again? X cubed minus 9x all over x squared minus 4, correct? So negative 4 cubed is negative 64. Negative 9 times negative 4 is positive 36. So what's that, 28? Negative 64 plus 20, or plus 36, I think is 28. $16 minus 4. Oh, negative 20. That is 12. Right? Okay, negative 28 over 12. That's a little bit more than negative 2. To me, now, granted, I've been doing this a little bit longer than you have, but to me, with that being down there, that would tell me that this function is going to go like that in this zone. Would you agree? Because it's got to end along an asymptote. Okay? then let's try -1. -1 plus 9 is 8. +1 minus 4 is -3. So that's -2 2/3. Then we've got +1. 1 minus 9 is -8. 1 minus 4 is -3. So that would be +2/3. So to me, that would say that this middle section waves on through. +4 would be 64 minus 36 would be 28. All over +12. So then that's going to be a little bit more than 2. Which to me would say and along our asymptotes. Yes? Love it. Good times. Yep. So, for the rest of the class today, so I'm giving you a half an hour. You can do the rest of this week's worksheet and even possibly turn it in if you want to. Totally fine with that. And then the very last page, I believe, in that packet is it 1 page or is it 2? It might even be 2 pages. Yep, so 2 sheets. So the week 16 worksheet is the Unit 4 review packet. Okay? So you got plenty of graphing that you can be working on.